Hi everyone, welcome back to my YouTube channel lecture series on microcontroller and ARM processor. In this video, I'm going to explain how to interface and program the ultrasonic sensor with Arduino. Ultrasonic sensor is a device that measures the distance of an object or obstacle by sending ultrasound waves. Ultrasound sensor has a frequency of 40 kHz, which is higher than the human hearing frequency. The human hearing frequency ranges from 20 Hz to 20 kHz. So it travels faster than the speed of the audible sound. In this video, I have taken a model of HCS R04 ultrasonic sensor, which has two circular structure. One is a transmitter and another one is a receiver. So transmitter transmits the ultrasound waves while the receiver receives the reflected signal. It also consists of four pins. One is a VCC, first pin is a VCC, second pin is a trigger pin, third is a echo pin, and fourth is a ground pin. For interfacing the ultrasonic sensor with the Arduino, we need to have these components. So we need to have ultrasonic distance sensor, then Arduino Uno board, and we have some set of wires. Coming to the technical specification of HC-SR04 ultrasonic sensor, the working voltage is DC 5 voltage, so we can use a 9 voltage battery for this. For measuring the distance of an object. Then working current is 15 milliampere, working frequency is 40 hertz, maximum range is it can able to measure the distance distance of an object is 4 meter, and the minimum range is 2 centimeter. Then measuring angle is 15 degree. Beyond this angle, like below 15 degree or above 15 degree, it will not sense a obstacle or an object. So the measuring angle is 15 degree. Within this range, within this angle, any object comes, it will sense the object and it will measure the distance. Then the trigger input signal is we have to give 10 microsecond high pulse to the ultrasonic sensor, so that the transmitter will transmit the sound waves to the towards the object. Then the object reflects the signal back to the receiver, and the resolution of the ultrasonic sensor is 3 mm. Now coming to the Arduino Uno R3, the Arduino is a microcontroller board that is based on Atmega 328P. It has digital and the analog input and output pins, which is generally used for interfacing with the ultrasonic sensor, which we are going to send the data as well as receives the data. And also it consists of serial monitor, which will display the output. This is a connection diagram of interfacing ultrasonic sensor with the Arduino Uno board. As I already mentioned, ultrasonic sensor has four pins, which are VCC, trigger pin, echo pin, and ground pin. Now we'll see how to connect this pin with the Arduino board. I have used this trigger pin connected to the Arduino board of the 9th pin of Arduino board. So I'm going to use the digital pins for this. An echo pin of this ultrasonic sensor is going to be connected with the 8th pin of Arduino board. So here the trigger pin is used as a transmitter pin, which is connected to the pin number 9 of Arduino board, and this trigger pin has to made high, then only it will transmit the signal. So the trigger pin should be high and it can be used as a output pin. And the echo pin is nothing but a receiver pin. It is connected to the pin number 8 of Arduino board and it is used as a input pin. And apart from these two connections, we have two more pins which are VCC and ground connection. So the VCC of ultrasonic sensor is taken and it is connected to the VCC of Arduino board. So the VCC of Arduino board is 5 voltage and the ground of this Arduino is connected to the ground of the ultrasonic sensor. Before moving into the programming part, you must understand how the ultrasonic sensor works. This ultrasonic sensor has two pins. One is a trigger pin, which can be called as a transmitter pin, and we have an echo pin, which is called as a receiver pin. So the transmitter pin transmit the ultrasonic waveforms, and the receiver receives the reflected waveforms. It has totally 8 cycles of ultrasound wave have been generated. You can see, look at this picture. We have 8 cycles of ultrasound waves at 40 kHz is generated when you give a trigger pin of pulse input of 10 microseconds. If you give 10 microsecond pulse to the trigger pin, it will take 8 cycles of ultrasound waves at the frequency of 40 kHz. And then the echo pin reads the time of the ultrasound waves and it takes in terms of microseconds. So this is a general formula used for calculation of distance. and we are going to calculate the object distance. So that I have taken 1 by 2. 1 by 2 is nothing but the time taken to reflect the signal back to the receiver. So d is equal to 1 by 2 t into c. D is the distance of the object or obstacle, and c is the speed of sound in air, which is 0.034 microseconds. So this is the programming code. You are going to use two pins. I already mentioned the 9th pin is used as a trigger pin, and the 8th pin is used as a echo pin. So trigger pin is nothing but your transmitter, and echo pin is nothing but your receiver. So you have our input and output pins. Then I am going to use a variable called long. The time can be in terms of milliseconds or microseconds. So we can use data type as a long, and other things we can use integer data. So I am going to use int trigger pin, int echo pin, int distance. Only the time I have taken a long data type because the time can be in terms of microseconds or milliseconds. Okay. So what I am doing is I am just initialize all the variables and the pin connections. I have declared the first stage of my program. So whenever we write a program, first we have to initialize or declare the pin connections and the variables which is required for the program. Okay. So the next step, I am going to use a loop, that is a void setup. This loop will run only once. Okay. So you can define whatever the pin connections you have that can be defined inside this loop. This will run only one time. Okay. So here I am using a pin mode. The 9 is a trigger pin I am going to use. This trigger pin is taken as an output pin, and the 8 is a echo pin that I am going to take it as an input pin, and you are going to communicate the serial monitor. Okay, so I am going to make a communication to the serial monitor, so that I am initialize the communication process by using the baud rate of 9600. This is a baud rate for communication. Okay. So next what you need to do is you can just start writing your program. This program will run continuously to measure the distance. So that I am using a the syntax or void loop. This loop continuously runs to measure the distance. Okay. So first what we need to do is we need to before transmitting the signal, we have to make the transmitter's pin to be low. After certain delay, you can just make the pin high so that it will transmit the signal towards the object, and it will take some time to reflect back the object to the receiver. Okay, so everything you are going to have some delay of in terms of microseconds. Okay, so the first step, I am going to write a digital write. I am going to make this pin as low. The 9th pin is low. I am just clearing the transmitter pin as low. Okay, so next step, I am going to create a delay, the delay for 2 microseconds. Then I am making the pin as high, which means you are going to activate the transmitter, which will transmit the ultrasonic signal. Okay, then I am creating again a delay in microseconds. I am just keeping some 10 seconds of delay. It is given before you transmit the another signal. Okay, so that I given some larger delay here, but here you can see that after the pin is kept low, I am making the pin as high to transmit the signal, but the delay which I have given is very less. Okay, so this is to give a low and then high to activate your transmitter, but here the 10-second delay is given to transmit the next set of signal or next another signal. Okay, so I have given a highest delay over here. Then I am going to use digital write 9, low. So you are going to clear the trigger pin again. Okay. So again you are going to clear the trigger pin. So now the one signal is transmitted towards the object or an obstacle. Okay, now we need to calculate the time taken to reflect the signal back to the receiver. So how do you find out the time? The time is equal to pulse in 8, high. So what is the 8? The 8 is nothing but your echo pin. Okay, so the echo pin is used as a input pin. Okay, so you are going to input the ultrasonic waves to through this 8th pin. Okay, the echo pin is made high to activate your receiver. Okay, this pulse in function is read the length of the pulse from the echo pin. Okay, and next step you need to calculate the distance. Distance I already mentioned the formula in the previous slide. Distance is equal to time into 0.034 by 2. Okay, so what is the distance? Here the time of flight into 0.034 is nothing but the travel of sound in the air. Okay, divided by 2. At 20 degrees centigrade, the speed of sound in air is in terms of microsecond, that is 0.034. Okay, so we divide this value by 2 because the signal hits the object and bounces back to the receiver. Okay, the next I'm going to use the syntax serial.print distance. You are going to print the distance measured. Okay, and if you want to print a new line, you want to continuously measure the distance. Whenever it sends an obstacle or object, it has to sense the object continuously. For that, I'm using again one more instruction, one more set of syntax, that is serial.println. This is you are going to print a new line. Okay, distance, it will keep on print the distance, if the distance between the sensor and the obstacle. If the obstacle is keep on moving, it keep on measures the distance with whatever it is given in the ultrasound frequency range. It will sense the obstacle and it will bounce the signal back to the receiver. Okay, it will keep on print the values in the serial monitor. So where we can use this kind of ultrasonic sensor is whenever you have a target size which is very bigger, and the reflected signal become stronger, and it can be used for more accurate distance measurement. And this kind of sensor are generally used in parking assistance system, collision avoidance system, anti-theft system, and also to find the water level of the tank. Thank you for watching.